Hello everyone. In this lecture I am going to discuss inference rule or Armstrong axioms, or you can say the properties of functional dependency. Here some properties are of functional dependency which we'll use when we'll find out some keys and the closures. For that we'll use these properties, so we have to understand it properly, right? So let's start. First property is reflexivity. Reflexivity property is just like trivial functional dependency, because if the functional dependency is given, suppose the functional dependency is A to B, and if we are saying that this functional dependency is trivial, if a functional dependency is trivial, then that functional dependency will definitely exist, means that functional dependency is valid. So if the functional dependency is trivial, then there is no need to check for the validity of that functional dependency. That would be valid, right? Keep this point in your mind. Okay. Now focus on the reflexivity. See, if y is a subset of x, then x determines y. Simple, right? If we are saying that SID CID is determining SID, right? And if we are saying that SID is the subset of SID CID, then definitely SID CID will identify SID. This is the property, right? Or you can say if uh, if this is given, like D can identify B attribute, right? Then we can definitely say that D will definitely identify D also. So D will identify two attributes, D to B as well as D to D. So we can write D is identifying B and D, two attributes, right? So this property is known as trivial property, or you can say reflexive property also. So simple rule is there: if y is the subset of x, then x determines y. Simple. Now the second property, augmentation. Augmentation property says, see with the example, if we have x to y functional dependency, this is given, right? Then if we add some attribute on both sides, left hand side as well as right hand side, then this function dependency will also be valid, right? Because we are adding same attribute on both sides. That is why the new functional dependency will also be exist, right? See in this example also, if we are having A to B attribute, right, this is a given functional dependency. Now we have to identify that the means this is the first functional dependency and this is the second one. So if someone asks that these two functional dependencies are existing or valid or not, then how we'll say? We have to check for first functional dependency, that yes, A to B is given, A can identify B, okay, that is valid functional dependency. Then if we are adding the same attribute, that is C, on both sides, then we can say AC can identify BC, and this functional dependency is also valid. That is the property of augmentation, right? Now the third property, transitive rule or transitive property. It is very simple property, and the property is, if, see the example, x is identifying y and y is identifying z, then definitely x will identify z. This is the transitive rule, right? So If x determines y and y determines z, then x must also determine z. Right? If these two functional dependencies are given, like first is this and second one is this, then we can say definitely this will be a valid functional dependency. Right? So this is transitive rule. Now the other rule is union rule. Now here again, first focus on the example, union rule. If x to y is given and x to z is given, means we can identify y with the help of x and we can identify z with the help of x. So now we can merge these two attributes, means for right hand side we can merge. So we can write these functional dependency, means according to these functional dependencies we can write this. Yes, x can determine both the attributes y and z. This is union rule. Right? Now the next rule, is decomposition rule. Right, now the decomposition rule is, if x to y z, means x can identify y z, then we can decompose this functional dependency. It is just opposite to union. See, x can identify y and z, so we can write that x can identify y and x can identify z. We can decompose these attributes. Right? So decomposition rule is also very simple rule. But remember one point, if we have a functional dependency like this, if AB, just a minute, if AB is identifying C, okay, and now you can see here we have two attributes, but according to decomposition rule we cannot write this like this, A can identify C and B can identify C. No, this is wrong. Why? Because see this functional dependency, here we can say that A and B combinedly identify C attribute. Okay, alone A and B cannot identify C. That is why these functional dependency will be wrong. Okay, so decomposition rule will only be applicable for right hand side attribute. It is not applicable for left hand side attribute. We cannot decompose left hand side attribute. Remember this. This is the decomposition rule. Now we'll focus on next attribute, that is pseudo transitive. It is kind of transitive property. Here we can say that, see, x to y is given if we can identify y from x, and see here another functional dependency is given, yz can identify w. So here we are replacing y with x. Can we write here x, z can identify w? Yes, we can write. Okay, why? Because x can identify y, so we can directly write here x, means xz can identify w. Right, so this is pseudo transitivity. I hope you understand. Clearly we can see here that we are replacing y with x due to this functional dependency. Right, so this is pseudo transitive. So these are the properties of functional dependency, and we'll use it in our next topic, the closure properties and the keys, super key, candidate key, for that concept also we'll use these properties. Okay, thank you.